Today we're going to discuss about special right triangles. Before we discuss the special right triangles, let us review the Pythagorean theorem first. So a squared plus b squared equals c squared, where a and b are the legs of your right triangle and c is the hypotenuse of your right triangle. So let's get down to business. The first type of special right triangle is the 30, 60, 90 right triangle. The theorem states that in a 30, 60, 90 triangle, the length of the leg opposite the 30-degree angle is half the length of the hypotenuse, and the length of the leg opposite the 60-degree angle is square root of 3 times the length of the other leg. It's better for us to examine this using the 30, 60, 90 triangle and how we can derive it. In the 30, 60, 90 triangle, it is actually based on an equilateral triangle, which is also equiangular, because this is an equiangular triangle. Then you know that this is 60 degrees, another 60 degrees, and another 60 degrees. So the best way to analyze this figure is to draw an altitude from this vertex up to this side right here. And if you draw an altitude, then this 60-degree angle is going to be bisected, and that is now going to turn to 30 degrees. Please understand that from the beginning, this triangle is equilateral, which is also equiangular, and because it is equilateral, if I assign any values here, this side, all the sides are equal. Therefore, this side right here is now going to turn to half of this side. So if this is 10, this is going to turn to a 5. If I'm going to label this as my A, B, and C, based off of this relationship, we all know that whatever your C is, your B is going to be 1/2 of C. And the reason why that happens is because this side right here is actually half of the whole stretch of a side of an equilateral triangle. So whatever is your C, which is considered as your whole piece, your B is going to be half of that. So now let's go ahead and derive the A. Let's use this to derive. So now we are going to have A squared plus B squared equals C squared. And now what's missing is the A squared. I'm now going to put the B as 5 squared equals 10 squared. This now is going to become 100, and this is 25, and this is A squared. So your A squared is actually going to become 100 minus 25, thereby having it as square root, this is now 75, that's 75, and if I'm looking for A, then I need to get the square root on both sides, and A squared is, A is square root of 75. And we all know that that is equal to 25 times 3. And 25 is a perfect square. Therefore, my A is 5 square root of 3. According to the theorem, A is going to be square root of 3 times the B. So let's review what we did here. We have solved for A, and this is the A we're looking for. And this was also mentioned on the theorem that the leg or the side opposite the 60-degree angle is going to be square root of 3 times the length of the other leg. So if your other leg is 5, that's the other leg. All you need to do is to multiply that by square root of 3. So therefore, this side right here is really 5 square root of 3. And in our formula, it's going to be A is equal to B square root of 3. So let's solve this real quick. Example number 1. If you have a 30, 60, 90 triangle, and you know that your C is 20, we all know that this is like the half of the equilateral triangle. So therefore, we know that this piece is 10 centimeters. If you want, you can use the Pythagorean theorem for this. It will give you the same thing. However, if we use the theorem, which is going to help us out quickly in the calculations, it's whatever this side is, the side opposite the 60-degree angle is going to be square root of 3 times the other leg. So this side is 10 square root of 3. Let us go to example number 2. What is given is the side that's opposite the 30-degree angle. All I need to know is that when this was still like a full equilateral triangle, then that is half of what I have for all the sides. Therefore, I know that this side is going to be 8 inches. And again, if you have not memorized the relationship of the 3 sides, and you can always refer to the Pythagorean theorem. However, all you need to do for the side opposite the 60-degree angle is take the side opposite the 30-degree angle, which is 4, and multiply that by square root of 3. So those are the sides. For our third and final example on a 30, 60, 90 right triangle, this time I'm giving the measurement of the side that's opposite the 60-degree angle as 9 square root of 3. So what happens is, based off of the relationship, we know that B is this right here. So that is your 9, because this side is square root of 3 times B. So if it's coming out to be this, then you know that that's B, and this is the square root of 3 based off of the formula. So now we know that this is half of C, therefore C is double this amount. So your C is 18. The next type of special right triangle is the 45, 45, 90 right triangle, and the theorem states that in a 45, 45, 90 triangle, the length of the hypotenuse is square root of 2 times a leg. So if a while ago the 30, 60, 90 is based off of an equilateral triangle, a 45, 45, 90 right triangle can be derived using a square. To better understand this, I have separated the 45, 45, 90 from the square and placed it here. So these are the two legs. A and B are equal. Please understand that A and B in this particular case are equal. So let's go ahead and derive how to get the theorem. So we're going to use the Pythagorean theorem, which is A squared plus B squared equals C squared. However, A and B are equal, so I can just say A squared plus A squared by substitution property. I can substitute this because they're equal anyways, because this is a square. So therefore, I can have 2A squared is equal to C squared. And I will look for my C. And to look for the C, I will have to get the radical here, get the square root, and that will be a C, and this is going to be A is perfect, so I'm taking that out, and 2 is not, so it stays inside the house. This is a proof that the length of the hypotenuse is square root of 2 times any of the sides. I know it says here A, but A and B are really equal. So it's just the same. So example number 1, what is the measurement of all the sides? So in this case, this side is 3 centimeters, but you know that this is isosceles. Well, it came from a square, so all the sides are equal. Therefore, this is 3 centimeters as well. And based off of the theorem, it's going to be, the C is going to be any of the sides, which is 3 square root of 2. Once again, we are only using all these theorems and all this relationship because we want to kind of shorten the process. However, if you had forgotten about this, you may always refer to Pythagorean theorem and it will always give you the answer. So for our example number 2, if the hypotenuse is 5 square root of 2, then you know that this side is 5. And of course, this side will also be 5 because that's isosceles. For my last and final example, what if the given hypotenuse is a whole number 12? So if it's a whole number 12, then you will have to do your equation, which is C equals A square root of 2. And absolutely, you're looking for A. You're looking for A and B. So this is A, this is B. So now this is 12 equals A square root of 2, and we're going to divide that by square root of 2, divide by square root of 2, and A is that. Please understand that in math, a denominator that's radical is not permitted. So let's go ahead and simplify this. For you to be able to simplify that and to get rid of the denominator of square root of 2, this is what you're going to do. You're going to multiply this by 1 in the form of square root of 2 over square root of 2. Understand that if I do that, I'm not changing the value because that's equal to 1. But I'm going to change the appearance because it's going to become 12 square root of 2 over square root of 4. I'm sorry, guys. I am so sorry. It's supposed to be not together. Okay. So now your A is going to become 12 square root of 2 over square root of 4 is 82. Okay. So because of that, as you can see, I was able to remove the denominator of square root of 2. And this cancels out. And your final answer is 6 square root of 2. That is the value of A. And that is the value of B.